Here's Canvas homework 0101. Let's see. A 7-meter stretch string clamped to both ends. What's the longest wavelength standing wave it can support? So you may not need to, but I always like to draw these things. So we've got a wall with a string clamped at both ends, and this length that we usually label, or distance we usually label D, the distance between the clamps, in this case is 7 meters. So you could just use the formula. You could say string clamped to both ends, the wavelengths are 2L over M, and you would say the longest is M equals 1. So you would immediately get 14 meters, which is the correct answer. But you could also think about it and really not even use the formula. Remember, a standing wave has to be a sinusoidal shape, and it has to obey the boundary conditions. So if we think, how could we fit a sinusoid between these two clamps along that line? You could just put a sinusoidal, a full cycle in there. That would work. You could also put, 2 cycles in there. That would work. Well, let's think, to get the longest wavelength, you could actually put a half of a sinusoid in there. That's another option. So this is the wavelength of this one would just be the separation. The wavelength of this one looks like it's half the separation. The wavelength of this one appears to be twice the separation, 2L. And really, these just correspond to M equals 1, M equals 2, and there's actually M equals 4 because we could have cut it off a little earlier. So use the formulas, know that we're referring to M equals 1, or just use the idea of what it's like to clamp a sinusoid. And here you would get twice the separation, which also, of course, is 14 meters. It then asks, what if one end of the string is free? So if one is clamped, and one can move up and down. And you may remember in class or talking to you one-on-one, I said, well, in principle that could happen, but that's not real, so we never ask questions like that. It's always so cute when I tell you things like that and you believe me. It's very, very endearing. But of course we did ask that. I forgot that we did ask that. So in that sense, it's kind of like an open-closed pipe when we're doing the sound waves. One end is clamped, one end is free, and this end that's free is always going to be an antinode. We didn't get into the physics of why, but that is the case. You would always have an antinode at the right. So what is the longest standing wave? Well, you could say for open-close, it must be this formula if you're into formulas. But the difference is where M is 1, 3, 5, M is the odd integers. And then you would say, well, again, the longest wavelength is the lowest M. So actually the odd integers don't matter. The answer is what, M equals 1. So 4 times 7 is 28 meters. But you could also do this one intuitively. It might be better to say, well, let's see. If it's clamped, and that's the horizontal, I could start a thing like that, start a sinusoid and just end it a little early. Be one possibility. You could go through a whole cycle, and then maybe a little bit of another cycle, maybe. But the longest wavelength that you could make would be to just start clamped and then just go to 1/4 of a cycle. And then the whole thing would come down and do another 1/4 of a cycle, another 1/4 of a cycle. So this is 1/4 of the whole length of that wave. Therefore, 4 times 7, also 28. So if you're good at formulas, that's good, but I think understanding these normal modes intuitively is very helpful for the kinds of questions we like to ask.